Hello all, welcome to tonight's Sanctum event, Nature's Game Changer with Atul Agrawal. So Ethan and I met Atul at the Sanctum Psychedelic Conference that we had here. If anyone was here for that, rock and roll. And we were immediately blown away by this man's life's work. I mean, it's really fascinating what he's gotten himself into. Atul began his journey with a bachelor's degree in metallurgical engineering, followed by a master's degree in material science and engineering. Over the past 6 years, he's been a dedicated member of the Intel family, shaping technology and processes as a process engineer. While his journey with Intel was rewarding, his curiosity led him down a new path as he delved deep into the realm of mycelium with a view to contributing to climate change solutions. His focus lies on comprehending the mechanical properties of mycelium and their application across an array of domains, including leather, foam, packaging materials, artificial meat, and construction materials. Hell yeah. Definitely time for that. This quest for knowledge and sustainability has prompted him to pursue a PhD where he will dedicate his life to extensive research in these vital areas. Sanctum is a nonprofit psychedelics research, educational, and harm reduction organization located in Portland, Oregon. Since forming in 2018, Sanctum has hosted a variety of speakers knowledgeable in the latest cutting-edge advances in psychedelic science, history, anthropology, and spirituality. We, through the Sanctum Psychedelic Conference in July 2023, host the Sanctum Open Mic every Monday and facilitate monthly integration circles. This past September 2023, Sanctum opened a brick-and-mortar psychedelic education center and nonprofit thrift store to make psychedelic-assisted therapy and information more accessible. If you have any questions about that, we do have a mailing list, or you could talk to either Eden or me after the presentation, and we could tell you a little bit more about what we're doing, essentially raising money so that marginalized peoples can have access to psilocybin and ketamine therapy. As we know, they are somewhat legal in this state, but the cost is really high. So we come in and we defray the cost for people that can use these kinds of treatments. We also wanted to give a shout out to the Portland Psychedelic Society for helping us promote this event. So thank you to PPS. And we are so happy to bring you Atul Agrawal.
Hello everyone, how are you all doing?
Woo!
Yeah! I am Atul Agrawal. Thank you Eden and Tom for hosting me. You have already heard my introduction. So, all my teenage years up till I was 20 years old, I lived in the city called as Jaipur. It's in northwestern part of India. Beautiful city, lots of history, culture, lots of castles. But the amazing thing was food. Oh yeah, there's loads of food. If someone like my friend loves Bollywood theater here, it's just the tip of the iceberg. The flavors, it's amazing. So after my, I went to bachelor's for my metallurgical engineering degree. After that, I worked for Yamaha for 2 years. I was the quality engineer for engine plant. We used to make engine parts like crankshafts and the assembly, the casting, all interesting stuff. After that, I came to Illinois, Urbana-Champaign for my master's in material science and engineering, where I worked on metamaterials. After that, for 3 years, I was in Hillsborough from 2017 to right before the pandemic. And because of visa issue, my company transferred me to Ireland. For 2.5 years, I stayed there, but the Irish society, it's very, very climate conscious. So as I was integrated into the society, I kept hearing about this climate crisis. But being in the US, it felt like, yes, climate was an issue, but it was far off. It was like end of the century. But when I was talking to multiple people in Irish society, they prompted me to learn more about the climate crisis. So I came back to US last October, But something had changed in me, so I couldn't just not stop thinking about it. So I knew that I wanted to do something. So I learned about fungi and got hooked into it. So I decided to do my PhD with primary focus on finding solutions for climate solutions and in the terms of materials. So this presentation will be divided into 5 sections. The first we'll talk a little bit about climate, like why is it a crisis at this moment. Followed by we'll study a little bit about fungi and then how fungal remediation processes have been implemented by visionary Paul Stamets. After that, we'll look into some companies which are at forefront, which are disrupting multiple industries like fashion, construction, as Tom talked about. And at the last, I'll give you a sneak peek of my PhD topic. Okay, so let's start with climate. So in last decade alone, we have experienced multiple climate extremities, from fire raging from Australia, Siberia, California, floods in Bangladesh, India. Entire northern hemisphere has experienced some or the other form of heat waves. We are risking crossing over tipping points which can bring our planet from being in a state of our most resilient friend, dampening our efforts, amplifying the heat, and becoming our strongest foe. We are seriously, for the first time in history, we are forced, and I underscore this, we are forced to seriously consider the risk of destabilizing the entire planet. The younger generation can see this. They are walking out of the school, demanding action, and looking at us at utter disbelief for our inability to deviate from these catastrophic risks. What we do in this decade will determine the future for the future generation, for many generations to come. Now, since you know about me, so when I started this journey, I was starting to finding why there is a 1.5 degrees centigrade goal, 2015 Paris Climate Accord. Does anyone know, like how many people know why what is the scientific evidence of 1.5 degrees C? Why is it not 2 degrees? Why it's not 1 degree? Why 1.5? So, this is the most important graph. If anything I want you to take away from this presentation is this graph. So what you are looking here is the temperature of a planet compared to a pre-industrial level for past 10,000 years. So as you can see, our planet, our beautiful blue planet, was able to stabilize the climate within plus minus 1 degree centigrade for 10,000 years, and this period is called as Holocene. It is the most stable time that we know that Earth has experienced, and this stability is critical to the civilization as we know it, because it was this stability that created the seasons, the 4 seasons. And it's not a surprise that right before 10,000 years we were hunters and gatherers, and roughly around 10,000 years ago we became from hunter-gatherers to farmers. And it was this stability that stayed for 10,000 years that enabled the human civilization to grow and prosperous and build societies as we know. So this stability is the key, right? Let's zoom back a little. This is the temperature as compared to the pre-industrial level for 3 million years. As you can see, the Earth has fluctuated between plus 2 degrees from to warm interglacial periods where we are surrounded by 2 polar ice caps and liquid water in between, to minus 4 degrees centigrade, which is deep ice age. So this Earth has never crossed over 2 degrees centigrade point. So that's why in the IPCC report we always say 2 degrees is the limit. We should be well below 1.5. That was the reason 1.5 was selected. And it is this Goldilocks zone, not too hot, not too warm, that has led us in this stable climate. Where we are heading now, as per the latest IPCC report, we are heading towards a 2.7 degrees centigrade, around 3 degrees, with 60 to 70% certainty by end of this century. So we are way above our climate goals. Now, this is concerning. We will be rewinding the clock not 1 million years, not 2, but at least 5 to 10 million years. This is a big deal. For every 1 degree increase in the temperature, for every 1 degree centigrade increase in the temperature, it is expected that 1 billion people will be living in conditions which are today considered uninhabitable. This is not a climate emergency, this is a planetary emergency. So, all this framework, how do you know what is the mechanics of our planet? So the scientists in 2010, especially the Swedish scientist Johan Rockström, he collaborated with thousands of scientists across the globe to study how our planet works. And he came up with this framework in which our planet is controlled by a set of boundaries. A set of boundaries which he calls as planetary boundaries. So you can say like land change system, freshwater use, ocean acidification, atmospheric, aerosol loading, stratospheric, ozone depletion, novel entities, climate change. But all these boundaries, they determine like what is the risk if we deviate away from safe operating zone. So what you are seeing here in green is the limit or is the risk that we can take for each particular boundary, after which the warning or the risk increases, and when if it is in deep red, we are in trouble. So along all these boundaries, there are two main boundaries, climate and biodiversity, and these boundaries are deeply interconnected with each other. So if we take over one boundary, the risk of crossing over the next boundary increases significantly. Now nobody is saying that Earth is going to cliff on January 1st, 2050. Well, nobody is saying that. What the risk is that we press these irreversible change buttons that we cannot back off. Like you cannot say in 2050, oh, I didn't wanted the ice caps to melt, oh, let's reverse it. No, it's too late. The reason for that, like if you think about the climate, the greenhouse gases like CO2, the CO2 stays in the atmosphere for hundreds of years. It's partly because of the reason that CO2 doesn't react with oxygen, so that's why it stays in the atmosphere for very long. So even if you stop the emissions today, all the emissions today, the warming that will be caused by the already existing CO2 is already at a level where we can expect about 2.7 by the end of the century. So we have to take action now. And these tipping over of these planetary boundaries by three risks. First, sea level rise. We can already expect 1 meter sea level rise by end of this century because of the melting of Arctic sea ice. But if you combine the water melting from Greenland and Antarctica, the sea level rise is expected further 2 meter high. That will endanger the life of our households for about 200 million people. The second risk is the thawing or our carbon sinks like permafrost and Amazon rainforests, which are deteriorating at an accelerated rate. So if they start belching out carbon rather than acting as carbon sinks, the job of stabilizing the climate will become even harder. And the third is all of these planetary boundaries are like set of dominoes. So if you trigger one change, it's gonna impact the others. So two important aspects here, climate boundary and biodiversity boundary are the two main core boundaries. When they came up with this system in 2010, only one of the boundary was showing some signs of extreme deterioration, that was the Arctic sea ice. Rest of the boundaries, when they calculated, it was about 50 to 100 years, that's what they thought in 2010. When they revisited in 2020, they got this shock because if you just take climate boundary, the climate is determined by 15 big biophysical systems on this planet. And out of those 15, nine of them were showing signs of serious decline. The first one, we are only few decades away from an Arctic without sea ice in summer. And what you are seeing here at the bottom is the sea ice cover as compared to the age of the ice cover. You can see like the ice cover extent is deteriorating at an accelerated rate as the years progresses. In Siberia, Alaska, the permafrost is thawing at a dramatic scale, and you can see that. And the problem with permafrost is that it emits methane. Now, methane is 40 times more potent than CO2. It stays in the atmosphere for much shorter time, but still, it's 40 times more potent. So we need to fix the methane emissions. Greenland is losing trillions of tons of ice, and maybe approaching tipping point. You can see this is the graph taken from NASA, and you can see the ice cover, the Greenland mass is continuously deteriorating as we are going. The great forests of North are burning with the plumes of smoke bigger than Europe. So you must remember 2021 Portland experienced a heat wave where the temperatures reached 47 degrees. Right? So yeah, these are becoming very frequent, and they will continue to become more extreme. 93% of the US was experiencing some form of drought, and not only US, Eastern Europe, Romania, Poland, they're all experiencing worst drought of this century. And as the temperature increases, the risk of forest fires and the forest fire cover extent increases. We all know about California's fire that happened, right? And because of these hotter temperatures, the agriculture is suffering. So in Africa alone, there are about 100 million people who are suffering some form of food insecurity. The Atlantic Ocean circulation is slowing down. So the Atlantic Ocean circulation distributes the heat from the equator onto the northern hemisphere. So if that circulation slows down, the distribution of heat will be uneven, and the hotter regions will get even more hotter, and the colder more colder. The Amazon rainforest is weakening and may start emitting carbon in 15 years. So the reason for that, so if you look at the forest has this wonderful ability to create a microclimate. So the trees and plants respire water vapor, and it creates a thick blanket, which serves as a microclimate, which is essential for the trees to grow. And if you deforest between the forest and with pockets, this microclimate gets disturbed, so the new trees cannot start producing, and eventually the trees will start to die back, and these forests turns into savannas and grasslands, emitting carbon in the process. This is called as savannahization. Half of the coral reef in the Great Barrier Reef is already bleached. They're dead. And it's a very, very serious issue, the coral reefs, because coral reefs inhabit some species which are at the base of many marine ecosystems. So if they are dead, the risk of extinction of biodiversity further increases. And coral reefs support like some of the most biodiverse ecosystems on this planet. And I'm reading like the species that they support varies from sea turtle, fish, shrimps, jellyfish, sea turtles, starfish, and many more. So they are literally at the base of many marine ecosystems, and half of them are already bleached because of marine heat waves. So as the ocean water gets warmer, the corals cannot support or cannot survive in this hot water, and they start bleaching. And coral reefs rarely come back after a bleaching event. West Antarctica may have already crossed the tipping point. Now this is a very scary graph. This is the number of standard deviation. You would see that we experienced a 6 sigma event in the West Antarctica sea ice cover. So every line here represents the Antarctic sea ice extent, but the line in red, you can see that in September, around September, in 2023, the ice cover went 6 sigma. So it has already crossed the tipping point. And now the most solid glaciers of all, East Antarctica, are showing signs of becoming unstable. And if you include melting of these big glaciers, we are expecting about 10 to 14 meters of sea level increase. So it's. Now let's look at some of the invoices which our Mother Earth have sent because of our actions, and they are not small. They cost billions of dollars. So as the hurricanes get more stronger, they have this ability to pass over warmer waters and hold more water. So this creates an atmospheric reverse, and they can hold up to 625 times the volume of our Willamette River. And so this is, on the left you are seeing one of the example of atmospheric rivers that stretched from Hawaii to California. This was in 2017. And they dumped all this water in a very short amount of time, which leads to flooding in 2017. And this again happened last year, if I remember correctly. This, in Germany, this was heavily covered in the news. In 2021, one of these rain bombs hit Germany. This was the scene prior, and this was the scene after one of the rain bombs hit. These are called as, they're calling it as rain tsunamis also. Another aspect, as we encroach more into the wildlife territories, there is the risk of zoonotic disease transfers. So on average, we are experiencing about 5 new diseases every year. And in 2021 alone, 75% of the new emerging diseases were zoonotic. So that was being transferred from wildlife to us. Corona was one such example. And it's gonna get more frequent, absolutely. So as you can see, climate has reached an emergency point. This is not just a climate emergency, this is a planetary emergency. And I'm still shocked that Facebook was not able. Yeah. So Tom was telling me that when they were trying to promote this event, Facebook restricted it because they consider climate as a social issue, right? It is not. It is not. Yeah, absolutely not. And we have ample scientific evidence to show that. Okay, so what is our mission? Our mission is 55 billion metric tons CO2. That is our carbon budget. This is the budget that we have up to, and at the current scale, if we don't decrease our carbon emissions, we'll run out of this budget by 2030. And to curb the emissions, we need to decrease our emissions by 7% each year. And how would you do that, right? And the goal is to reach carbon neutral by 2050. So 0. Whatever you emit, you absorb. That is the bottom line. If you see how you can combat, and you see the distribution of the greenhouse gas, 75% of it is CO2, 17% is methane, 6% is nitrous oxides, and then some others. So we need to stop burning fossil fuels now. And methane is agricultural waste related. So while I was looking for some way I can contribute to these climate catastrophe, I came across one interesting technology, CRISPR. Do you know about CRISPR? By the show of hands, how many people? Awesome. So CRISPR is a gene editing technology, and it received the Nobel Prize, the Jennifer Doudna and Amelia Charpentier. It's an incredibly precise gene editing technology. So if you print the DNA, it'll be like 3 encyclopedia thick, printed both sides. So CRISPR can go onto a particular page, particular line, particular word, can edit the word, copy paste, it will serve like a word processor. So there is one professor, Joanne Corey, who is working in Salk Institute, and she's working on modifying the roots of the soybean plants. So if you increase the length of the soybean plants, you can capture the carbon underground. So I became really interested in that technology, but while I was looking for the roots, I found fungi. Now fungi are just amazingly diverse and beautiful organisms. They're just not mushrooms, as you will know more. So fungi, we are more closely related to fungi than any other kingdom in the kingdoms of life. They can hold up to 30,000 times their mass. They are the soil magicians. They convert the dust, I would say, or particles into soil. They create the humid soils. They are expected about 15 million species to inhabit this planet. out of which 6 million are expected to be fungi, out of which we know only cataloged about 175,000, so roughly 2%. So 98% is unknown. They are more similar to us, like they breathe in oxygen and exhale out carbon. The only difference is they have like externalized stomach. So they secrete out enzymes, digest the food outside, and then absorbs it in the skin. One of the most ancient fossil records that we have of fungi is of the species called as prototaxocytes. 450 million years ago, there were these mushrooms like 26 feet tall, 5 foot wide, and at that time, plants were only 2 feet tall. So these big mushrooms dotted the entire landscapes, multiple landscapes on planet Earth. And this is an artist's rendition of how it might have looked. The largest organism on this planet is actually a fungi, and it's in Eastern Oregon. It's a honey fungus. It is 2,200 acres in size, about 2,000 years old, and it's a parasitic fungi. So it has cleared off all this forest. It's a big mycelium net, and each mycelium is made up of hyphae, which is just one single cell thick. Now, people still don't know how this organism survived for 2,000 years. Now, fungi, whenever I talk to my friends, my family, when I say fungi, they'll either think of death and decay or mushrooms. And yes, it's true, fungi comes in the mushrooms. There are about 10,000 species that produce mushrooms, and they are just beautiful to look at. For example, this whale stinkhorn, they evolved this veil so that the insects can climb up to the mushrooms and get the spores and disperse it. This is the bleeding tooth mushrooms. Some of the ants and termites actually farm fungi for their, like as a food source, and when they abandon the colony, these are some edible mushrooms, very delicate. This is our famous Mario mushroom, Amanita muscaria. This is the bird nest fungi. The fungi in itself has such a strong force and pressure, this is called as turbo pressure, that it can break the asphalt, as you can see. So they have so much power. And then there are some psychedelic mushrooms. Yes, psychedelic mushrooms that have been integrated into our human lives so much so that there is an hypothesis called as stone ape hypothesis. So the hypothesis is that roughly from 2 million years ago to 750,000 years ago, our brain size doubled in size. So this is like a blink of an eye in evolutionary timescales. So people have, McCain, one of the researchers, has proposed that when we were hunters and gatherers, while we were roaming around in the jungles, we will come across the manure, the cow dung, and there is this coprophilous fungi that loves to grow on the manure, and it is psychoactive. So the theory is that these hunters, our ancestors might have consumed this, it was part of their diet, and what these psychedelic mushrooms do is help you make associations. So, for imagine you can see the light, or you can, you can hear the light and see the sound. And that might have led to the development of language, because if you think of language is just a bunch of meaningless sounds being associated to a particular action. So this is the stone ape hypothesis that has been proposed. It's not a theory yet, it's not proven, but it's an interesting story to tell, right? Fungi has been integrated into human lives, like we use it to make bread, beer. Whenever you are eating pizza, you are eating fungi, whether it has mushrooms or not. The fungi has been used to make most of the medicines. About 30 to 50% of the medicines comes from fungi. And they can be genetically engineered to produce insulins, right? So let's talk about the life of fungi. So the fungi life starts with the spore. It's the seed, equivalent to the seed. And when the seed finds a particular environment which is conducive, it starts to grow these thick, thin white strands, which are 0.8 microns thick, up to 0.8 microns thick, and they continue to grow and branch out. And then as these, this is actually a real, under the light microscope image taken by the Toby Kears group in Amsterdam. So as they grow, make this, and they branch out, they create this net, which is called as mycelium altogether. And mycelium is so rich, it's practically everywhere. It's everywhere. In the single cubic inch of soil, there can be about 8 miles of mycelium present, and they'll only account for 25 to 30% of the volume. So they are very thin strands of white strands, and it is the hyphae. It's like a tubular structure, and it transports the waters and nutrients across the landscape. So as these net or mycelium encompasses landscape, they create these cavities of pockets where the microbes and the underground microbial community can survive and thrive. The most interesting feature, or the most interesting fungi that I love, is the one which make AM association. This is called as arbuscular mycorrhizae fungi. Arbuscular means dwarf tree, myco means fungi, rhizae means roots. So these fungi can penetrate the roots of the trees, and when they penetrate, they make these arbuscules, these dotted structures, the black dotted structures, and they serve as a physical point where the nutrient exchange can take place. So the fungi, since it can encompass miles and miles, they can bring in and transport nitrogen and phosphorus, which are essential for the plant growth, and in return, the plant gives them carbon. So much so that 30% of the sequestered carbon, or 30% of the carbon, actually goes underground into these networks. Almost 85 to 90% of the land plants make these associations. These are called, again, AM fungi. And Toby Kears group is actually leading a very interesting research where she's studying these relationships, and the fungi and plant relationship actually works as a market economy. So fungi can actually hold the nitrogen and phosphorus at one place to jack up the price of carbon. So instead of stocks and bonds, it's actually nutrients that is in the play. And this is the market economy, which is about 400 million year old. Sorry? Yeah. So that's our market economy, 400 million years old, and she's understanding how the fungi makes all these decisions about where to hold the nutrients and how much carbon. A single plant can make hundreds of mycorrhizal associations with different species, and they grow and die and they connect another time. As the roots grow, the new associations keeps on at play, and the associations usually last about a week, and after that the point of connection dies, and then the fungi again makes the connection. So what you are seeing here is the nutrient and water flow along one of the hyphaes. But one of the interesting points is, you can see on the right, that they can reverse the direction of the nutrient flow, and they can reverse again. So it's a bi-directional flow. So it serves as a circulatory network in the forest ecosystem, just like our arteries. Just like our arteries. So since they connect all these trees together, there is actually research that the mother trees can recognize their own children, and through these mycorrhizal networks can increase the competitive advantage when their seeds sprout. So because of this communication being flown across the forest ecosystem, this mycorrhizal network is sometimes also called as wood wide web. It's a play on World Wide Web. Because the communication is being exchanged. One of my favorite species within the AM kingdom is glomeromycotin. Let's start with their spores. Their spores are big enough to see through naked eyes. And the reason these spores are that big is that they can hold up to 800 to 35,000 distinct nuclear material. And which nuclear will sprout when they see, we don't know. We don't know. So there is so much history just within one single spore. And they come in various sizes, color, we just don't know why. What does the color plays into the significance? What does the size comes into the significance? And another part which I like about these glomeromycotin is that they are the only species that exude out glomalin. It's a red sticky substance that they excrete out from their hyphae. And as this is sticky, it binds the soil particles together. So as this network grows, it creates a structure which is porous yet stable and creates the first soils. And it is because of this porosity, the oxygen and water can seep down within the soil and can support the oxygen-breathing microbes underground. Glomalin is made up of 39 to 59% carbon. So much so, 1/3 of all sequestered carbon goes because of this compound. And they're the only species that we know of that make this compound. So they are essential for our ecosystems. Another interesting aspect, so by now you understand this mycorrhizal network. So there are some species of orchids which has lost their ability to photosynthesize. And these plants, these flowering plants, are fully white or red in color, and they are like the hackers of these wood white bed. So what they do is their roots will go into these mycorrhizal networks, and they steal all the carbon, nitrogen, phosphorus directly from this network. They don't produce anything. And you can find these from June to August in any of the hikes. Our Oregon soils are very fungal rich, so you'll find them along the hikes. I've seen it multiple times. I've taken my friend there too. So now that we know about fungi and climate change, how do these two interconnect? So here I will talk about the research and the work that has been done by Paul Stamets. So Paul Stamets and his team, they are working towards mycoremediation. Remediation means helping our environment or rebuilding our environment using fungi. So the first example of mycoremediation, they partnered with one of the companies in Washington state, and there was 4 piles contaminated with oil and diesel waste. One was the control pile, one was treated with bacteria, one with enzymes, and for their piles, they treated with oyster mushrooms. So fungi, as they absorb this oil and diesel, they perform peroxidases, which can break down the carbon-hydrogen bond and hence break down the organic matter. Right? So within 6 weeks, this happened. All the other piles were covered like dark, stingy. Their pile was covered with hundreds of oysters mushrooms. Some of them were so big, they were happy mushrooms because that much nutrient they can soak up from that pile, which was as a contaminant in the first place. But just using the natural resources, they were able to convert that pile into fungal sugars. But it didn't stop there. So this is, as he called, as the epiphany of his life. So as these mushrooms sporulated, they attracted the insects. Insects like larvae. Larvae attracted birds. Birds brought in seeds. And then within just 8 weeks, this turned into an oasis of life where there were trees, where there were plants growing from a contaminated base which was contaminated with oil and diesel. In just 8 weeks, the aromatic compound went from 10,000 to less than 200. So there is a recent article that I was reading that they are using human hair to soak up oil spills out in the oceans. And they, go ahead.
Actually, Paul Stamets was in San Francisco when there was an oil spill out of a container ship in the middle of crude oil in the very close to the San Francisco Bay, like in that area where they come in, and they ended up Paul Stamets was lecturing when this accident happened, and they ended up having him fly down a conglomerate of mushrooms spawn to spray on the oil spill, and it bioremediated and the first thing they did is they used hair.
Oh yeah, okay.
A woman who was made wigs for people that were dealing with cancer and losing their hair. She donated she would sell wigs to them to help them. And then what she did is she found out about the oil spill and she donated all the hair. But the problem is the hair got the oil and coagulated it, but it didn't get rid of it. So Paul Stamets ended up having helicopters spray the spawn, and it ate it up.
Awesome.
It neutralized it in a mix of salt water and fresh water. So that in itself had never been done before.
Exactly.
And that was done, I think that was like 8 years ago that happened.
And now, I was reading in the New York Times, about a few days ago, they have again used human hair to clean up the oil spills. In parts of Africa, parts of some villages are covered in oil spills because of very slack regulations there. Right? So this technique can be really helpful instead of using all the chemicals, and this is a natural way to help the environment. Thank you. What's your name? Sorry.
Dee.
Dee. Thanks for your input, Dee. Okay, so using this technique, the next example is of the microfiltration. So they created these bunker spawns, bird-like sacs, which was being infused with mycelium, and they placed it downstreams, collecting the waste from the farmlands nearby and the factories which are producing toxin waste. It looked like bunker spawns, and then they put it downstream. So as you can see, like in the downstreams, they were collecting the effluent waste from the nearby farmlands, factories, and as the waste and the toxic waste and bacteria like E. coli bacteria are collected within these filtration units, these fungi ate those bacteria, because we are so closely related to fungi that the bacteria that attack us, viruses that attack us, fungi also, they also attack fungi. So they have developed these kind of defense systems, but they are 1.3 billion years old. So they in the wildlife, we will have natural substances that can help us prevent all these toxins. So they lined up all these bird-like sacs and collected the water that was coming out. And this is the logarithmic scale. The top graph is for the E. coli, and you can see in just 48 hours, the concentration decreased 10,000 times. 10,000 times, just by using 3 mushroom species, as compared to the other control experiments that they did. And this is another for the yeast, similar experiment. Paul Stamets is typically, his favorite mushroom, if I have to guess, would be this agarikon mushroom. You know about agarikon mushroom? Yeah. It has a history of Chinese medicine. It was being used. It is exclusive to old growth forests, and we are lucky that we have it. Oregon, Washington, British Columbia, along this range they find it, and it's an extremely rare fungus.
What did you say the name of it is?
Agarikon.
If
Agarikon.
you watch the TED Talk with by Paul Stamets, he made a hat out of it.
That was Amadou mushroom, right? For the hat, Agarikon mushroom.
Agarikon was he does a TED Talk around the use of agarikon, and he helped his mother cure her cancer,
Right,
stage 4, and he had the agarikon made into a felt hat.
Oh, okay.
He actually, it was fibrous enough. Anyway, yeah.
Yeah, exactly.
So he wears that hat all the time when he.
So this mushroom is proposed to have medicinal properties, extreme medicinal properties. So they collaborated with the US Department of Defense, Bioterrorism Department, for smallpox viruses, for pox viruses. Now smallpox, you might not believe it, but anyone with a basic bioengineering degree can engineer that virus and can use it against us as a form of biothreat. So people are looking into solutions that we can implement at the mass scale. So Paul Stamets submitted about 300 samples by boiling these mushrooms and the mycelium to extract the extracellular liquids, and they treated the pox viruses. You cannot experiment with smallpox viruses due to some constraints. So they treated cowpox viruses. What you are seeing here, they submitted 3 strains of agaricon mushroom. What you are seeing in yellow is the selectivity index. So if the selectivity index is less than 2, it's considered as not active. Between 2 to 20, 2 to 10, it's considered as active, and above than 10, it's considered as highly active. So most of the species that they submitted of the agaricon were showing very good selectivity, about in 20s roughly. So as they were successful against the pox viruses, they naturally went towards flu viruses. And in the flu viruses, they compared the treatment against the ribavirin, the standard treatment. And you can see for the pox viruses, the selectivity index was roughly between 20s and 30s. But for the flu viruses, it was up in 200s and 300s. And when they submitted a blend of agaricon, reishi, and chaga, the selectivity index rose to 1,000. So it is a very, very active treatment against the flu viruses for the same dosage. Now let's jump into the another aspect, that is mycopesticides. So there is the class of fungi, entomopathogenic fungi, that infects the insects, the last of us. But instead of us, it's the insects, right? So what he did, he cultured the mycelium, and what you are seeing in the black portions is the spore producing mycelium, and the white one is the non-sporulating one. So mycopesticides for the termite industry, it's a very nasty business. They use a lot of toxic chemicals, right? Paris right now, if somebody is following the news, is in the midst of bedbug crisis, and they are about to host the Olympics. So it's a big issue. It was spoken in the parliament, like he should do something about it. So he wants to tackle that industry too. So what he did, he followed the non-sporulating mushrooms and cultured it, and gave it to the ants, carpenter ants that was infesting his house. And the thing about insects is that they avoid the spores of the mushrooms. So if there is a non-sporulating mycelium, they happily ate it, and they gave it to the queen. The queen died, and within a week, the population decimated of the carpenter ants. So just imagine the impact of it on the termite industry. It's a natural resource, and you can just buy this off Amazon, and you can just place it. Yeah, he has patented this technology, and he's working towards 200 species of the entomopathogenic fungi. But that list will continue to grow, right? As the fungi infects the insect, it eats it inside out, and they attack the nervous system. And it is actually interesting how the fungi does it. So in the forest ecosystem, when one of the insects will get impacted with this fungi, the fungi will attack the nervous system. It will make that insect climb up the tree up to a point where the fungus finds it suitable enough, humid enough for it to release the spores. And once the fungi has found that spot, the insect dies, and from its head, a mushroom sprouts up and releases the spores. So this will be last of us, yeah, basically, but in the cordyceps, yeah. So instead of us, it's the insects. So this was another application, the mycopesticides. So fungus has been used in these particular instances, and this particular field is currently dominated by a visionary Paul Stamets. If you need more information, you can read multiple of his books. Now let's talk about some mycelium products that you can buy today. Right? So there are, here I'll talk about 3 companies: Boltred, Ecovative, and Mycoworks. These companies are disrupting the fashion industry. So let's talk about fashion. Okay. So even if you hate fashion, there is an area inside your house which is dedicated to it, your closet. And your closet is made up of materials such as cotton, nylon, polyester, leather. And these materials matter. It is because of these materials the fashion industry is in the midst of the sustainability crisis. Last year alone, the fashion industry made 100 billion items. 100 billion items. Let it soak. This number, let it soak. We are 8 billion on this planet, and the fashion industry produced 100 billion items in just 1 year. And when there is one person, Dan Widmer, who is the founder of Boltred. So when he started looking into this problem, his story goes that when he started, it was an easy solution. Okay, buy less, consume less, so it'll be okay. But doing so, you are ignoring our fundamental human nature to consume more. So fashion is not just purely functional. It is an expression of self. It is our innate desire to want more, need more, show off, as it is an expression of ourselves. But we can make this sustainable. That is the good news, right? And we are going to do it with science. So when he was working for his PhD, he came across one material through which he was able to make artificial silk. And he made a silk tie, sent one copy to the Spider-Man director, no one's his name. Right, they geeked out about it. And he was very excited about it. So he took it to the fashion industry. And they were interested, but they kept talking about leather and leather. Now leather is environmental catastrophe material, because for leather we need to raise a lot of cows, and cows produce methane. And we are not talking about the small amount of cows, we are talking about acres and acres of cows. Now for you to replicate and find vegan leather, you need to see what makes leather leather. So leather is known for its soft yet strong, pliable qualities which make it rich and royal. So this is the microstructure. If you look at the leather under the microscope, this is how it will look like. It is a jumbled up mess of animal collagen being pressed up, and it is because of this microstructure that the leather gets its microstructural properties. So what we need to find is a material which looks and behaves similar to this. As compared to your normal other woven materials, they look like this under the microscope, a thread being crisscrossed over each other. So while in the search of finding an alternative material to leather, he was working towards plant collagens, developing collagens in the lab, but all of them doesn't work. The cost, manufacturability, the scale, it doesn't just work. And he came across the world of fungi. So he used mycelium, and mycelium is again like under the mushrooms, that is the white threads that you are seeing, those are the mycelium. And he used mycelium, and this is a microstructure compared from leather to mycelium. So it looks pretty similar, right? And for this, they created the prototype which was successful. But to tackle the leather industry, we are going to need a lot of leather. The 5 big Paris houses, European houses, sold $50 billion worth of leather products last year. So if we are going to tackle the leather industry, we need to produce mycelium at a very large scale. So that was his second challenge, how to grow mycelium. Because if you're going to extract the mycelium from the soil, it's again an environmental catastrophe. Right? So what they did, they take the mycelium, and they grew it on the agricultural waste. They grew it on sawdust, and they created this big, huge chambers. And the fluffy clouds, or white clouds that you were seeing, these are actually mycelium. But this is where the technology gets interesting, because mycelium is underground, and it's very hard to harvest it. So what they did is they changed the atmosphere in the chambers so that the mycelium has to come out in the search of air. So created these mycelium mats that they can easily harvest, press down, and make similar to leather. So they created this material, and this is called as Milo. This is their signature product from bolt threads. It looks, feels exactly like leather. And so the next challenge was implementation around the global scale. Right? So let's take, for example, spandex. Spandex was introduced in 1950s, was discovered in 1950. The same material that is there in the yoga pants, jeans, makes your butt look cute. So that material was introduced in 1950, but it was not until 2000 that it saw the wide-scale application. But thanks to climate change, we don't have 50 years, right? So we need to expand this material's reach across multiple industries. So this is where Dan was able to collaborate with the 4 big companies, Lululemon, Adidas, Stella McCartney, and Keurig. And Lululemon recently released this yoga mat made up of Milo. Adidas introduced their vegan Stan Smiths made up of mushroom leather. This is Stella McCartney's bag that was made from Milo material, and she introduced in Paris runway. I don't know the exact year, but it is already there. Based on this successes, this is not the only company. The other company, that is Mycoworks, their signature product is Reishi, pretty similar. The other company is Ecovative. Ecovative have taken one step forward. So they create leather. So this is the third company with the similar processes. But they also use mycelium to cut it and press it to make fake bacon. I don't know what exactly it is called, but I have never tasted bacon, I'm a vegetarian. But people say it, as per the reviews, it says it tastes, the texture, it feels like bacon. They have also created the foams that can be used in pillowcases, cushions. Currently we use polyester, which is really bad for the environment. They are also creating beauty products. So there is one component in the mycelium that, if grounded and applied to skin, it is helpful. So they are selling some facial cream products and some shampoos that I remember. So they are integrating this. Sorry, go ahead.
With the packaging,
Yeah.
what kind of movement is there to get it so that Microverse or Ecovative that do the packaging, they've been trying to approach for a long time, like
Right.
computer companies and stuff that,
Right.
that send computers and they have them molded, and then you just, when you get the computer, you just throw it in the compost kind of
This
thing, right?
Yeah, this packaging material, like this.
Aplos, is that the?
Oh, so this is just an example.
Oh, that's the way it's molded. Yeah,
Yeah,
I mean,
exactly.
that's been around for a while,
Yeah,
right?
yeah.
I'm just wondering how it's been promoted so that more people are using it, because we certainly still have a lot of the styrofoam and the polyethylene, all the plastics that are out there that are multiple companies are using, and probably Amazon is one of the worst. Why? Yeah.
So exactly. So this Ecovative company actually broke ground for their second factory about 3 to 4 years ago. So the problem right now is scaling. So it will come. It will come with scaling. So they are the Ecovative and Bolt Threads both have now 3 factories in total. So as this technology progresses, it will get integrated. And Ecovative actually partnered with IKEA.
With IKEA.
I think I have it here. In what year was it? there was any year they partnered with IKEA.
Uh-huh.
So IKEA's packaging, so this packaging material can be made from hemp and mycelium. So you just compact it and give it a shape. And the best part is once its life is done, you just break it, put it in the soil, it will decompose within 45 days. That's what they claim. Yeah. Let's talk in the construction business. So this was a tower that was being made up of 10,000 mycelium bricks. So they created these bricks using again hemp, straw, and they infused it with mycelium, compressed it, made it like a brick. Now, and created this 40-foot tall structure. Again, it's not even close to the concrete structure, but the concrete density is about 2,400 kilograms per square meter. This one only has 43 kilograms per square meter. So this mycelium bricks are finding applications in the insulation material. So along the concrete, they can line this up, and they are fire resistant too. So that's where we might find any potential applications today. This was another structure being displayed by Penn State University professor Bene Gorsoy. Yeah. She and her student displayed the structure just to show that the mycelium hold the strength to create structures which are big enough.
Any idea when that was displayed?
I think it was 2015.
Okay.
Were you there at that time?
I don't know, because I was at Penn State, but yeah.
You can say.
I didn't, maybe it was after. Yeah. I was saying that I recognize that, sorry. Go ahead.
Okay. So then the Touch sustainability project, they created this big auditorium kind of structure, but the focus or the main point was the panels that they grew out of mycelium, and they deliberately left it to grow. So that's what you are seeing below the curtains. And since it's a very good insulator, so it kept the building cool during the summers and warm during the winters. The lasting impact or how long it lasts is still under investigation, but under accelerated aging, they were able to predict that it should hold its shape and form for at least 3 to 4 years. So the research is continuously underway, and it's only going to get better and better. So these were the applications that are currently existing of mycelium. Let me just, I promise this will be the last slide. So whatever you have seen, the applications, the leather, so even when these companies are making leather, there are multiple problems, like the leather has to be uniform all across, but mycelium cannot, you cannot adjust the mycelium height uniformly across. What is the microstructure mechanics? What exactly determines the mechanical strength of the mycelium bricks? So all of these questions are not being explored. So there is a very significant gap in understanding the mechanical properties of fungal-based materials. This is the graph of the strength of the materials. On the y-axis you are seeing the Young's modulus, that is the strength, and along the density. So the fungal materials usually lie in these natural materials and polymer section, and the research is going towards expanding to get into the foams regions or elastomers, and even to metals. Professor Han Waston from Amsterdam, yeah, he's also working on increasing the strength of these materials, because mycelium in itself can make amazing structures. You can see it in the forms of mushrooms or rhizomorphs, which has been formed by Armelia mushrooms or the honey fungus. It's a very thick, melanized, tubular-like structures that infect the host tree. So this is where my research will be primarily focused. We'll be studying the monometic, trimetic, and dimetic systems. So there are 3 kinds of fungi, and we'll be studying how these 3 integrate to give a mechanical property to the end product of the structure. So this was all, but I think with the end of this presentation, if you are taking home with this shred of motivation to join this climate movement, right? Because it's not possible for a single soul, it's a collective movement, and we need every one of you. And the second aspect is fungi is not just mushrooms, it is so much more. And it's a very promising material, we will see more of it in the future. Thank you.
Yeah! Please, go ahead.
Along the lines of what she was asking, what about plastic?
Mhm.
Replacement for plastic. That's why I said about polymers in the last.
Yeah. We are, there are certain products that are being made through plastics. There is no commercial company which is making it. It's still in the research domain. There were some extracts that are being used, antifungal extracts, that can mimic the properties of plastics, but it's still under discovery. So there is.
You need like plastic bags and plastic.
Yeah, exactly. Yeah. Yep. Go ahead.
Agaricon, can they grow that in the lab?
The mushroom?
Yeah, the mushroom.
No.
It
It's
has-
exclusive.
It has to grow in old growth forests.
Yes. Why? We don't know.
Wow.
It's exclusive, and it's not just true with agaricon. Multiple of the mushroom species will not grow. These mycorrhizal networks that I talked about, they won't grow in the lab at all, because they need this ecosystem, the forest ecosystems. And that's why Paul Stamets says that protecting the old growth forest should be a matter of national defense, because there is so much in the forest that we don't know and haven't explored yet. Go ahead, Edith.
Where can we find your work or follow you?
Oh, I will be studying at University of Utah, and my professor will be Stephen Nailville. So any work that I'll be doing there will be available on his research.
Okay. And do you have a Twitter or any social media or anything?
I try to keep away from it, but I use Instagram to stalk people. So
Okay.
Yeah, go ahead.
So I've got another question. It's about Chernobyl. So there's all these reports about a radioactive, a fungus that eats radioactivity and transmute that.
Mhm.
What's your thought on that? Is that actually happening?
Oh, I have absolutely no idea. Sorry, I'm still learning. Yeah. Go ahead, John.
I have like a few questions, but I'll just narrow it down. So with maybe two, because the first one will be fast. The oyster mushrooms that sort of soak up oil, are they still edible after that or no?
Yes.
They are?
Yes. Why not?
Wow.
Yeah.
Well, yeah, I guess.
Yeah.
Well, I didn't know that. I have one other one.
Yeah, it's
yeah,
good.
that will be fast. With the mycelium, you talked about there were different colors, right, before, and we don't know why.
Mycelium or the glomeromyton spores?
The spores,
yeah.
Is it possible that they are those different colors to attract insects to carry them in the same way, like different like flowers are, the reason flowers are so colorful is to attract bees
Mhm.
and other insects to pollinate. Is that a possibility?
So the problem with glomeromycotin is that they are solely underground.
Oh, okay.
So how would you see it?
All right, well,
Yeah. But their seeds are everywhere, their spores are everywhere. Even in the sand dunes, for every cubic centimeter, you can find about 4 spores. In agricultural sites, it is about 5 to 95. And I think in the forest ecosystems, in a single gram of soil, there can be 1 to 5 glomeromycotin spores. They are widely spread. Like 85 to 90% of the plants make these associations, and their life depend on it. Yeah. Go ahead.
When the mycelium is compressed down into like bricks for like construction,
Mhm.
I'm curious what the durability of that is, and if like if biodegrading on its own as it is being used in construction is a problem.
No, so when we use these fungus, they will be dead. So they heat it above 40 degrees for more than 3 hours or 10 hours. Don't quote me on that. But if you heat the material, it will kill the fungus. It will not grow.
But nothing else will grow in it
No.
either? Okay.
Once it is dry. So it has to be dry. The beauty lies when you break it down and put it in an environment where the other fungi can attack and decompose.
There is a species that is an Oregon reishi that
Oh.
is just indigenous to the old growth forest here in Oregon.
Oh wow, I didn't know that.
Yeah, and yeah, my son's a mycologist, and so he cultivates a lot of medicinal and nutritional mushrooms.
Oh wow.
And we harvested some of the Oregon reishi, and
How did it look?
we're creating the mushrooms.
The reishi grows really, really slow, right?
What?
The reishi mushrooms grows really slow.
Yeah,
Yeah.
yeah,
So how did it look? The end product is always different.
it's gorgeous.
Yeah, so
Oh,
it
it's gorgeous.
forms a beautiful masterpiece. Yeah. The centerpiece, sorry. Yeah. Go ahead.
Are there, like you see, I was wondering about like mushrooms that are fungi that are killing these insects, right?
Mm-hmm.
So what about mammals? I mean, are there any fungi that will get in and kill us?
No. So currently, our body temperature doesn't allow the fungi, this particular fungi, the entopathogenic fungi, they cannot attack us because our internal body temperatures is too high for them.
Well, what about the people using the suits, the body suits that are made out of mushrooms for people that have died? So they choose to be planted in the ground because the mushroom suit will eat them.
They are also making coffins.
But they're
Just
Faster.
They're also making coffins.
It's too hot, so if you're dead, you don't have that same body temperature. Right?
I'm not sure, but
They're beautiful. Yeah, go ahead.
Have you or anyone else heard about fungi being used to eat plastic waste?
There has been multiple reports, but there is no scientific paper I could find. I was also interested in that question. If anybody knows, please let me know.
I heard about it.
Yeah.
Never found anything about it.
Yeah, scientifically I don't know, and that's why I don't want to say.
That would
If
be
anybody
great.
knows.
Yeah.
Definitely, because I mean, they are inventing the whole, trying to get the particles of plastic out of the oceans, but boy, it's a multi-million-dollar project, and yeah. I'm not so positive about that.
If there are any further questions? Oh, go ahead.
I honestly, my mind has been blown since you showed that slide of the mushroom punching through the concrete.
Yeah, yeah.
How?
So the internal pressure of the hyphae is so high, and it is the reason that's why the hyphae always grow along the tip. The pressure is, well, there are multiple theories why the pressure is that high. It's called as the turbo pressure. So initial theory said that, okay, there are these nutrients and water that is being absorbed along the fungal walls, and since it is very thin, the pressure is very high. But then the problem with that theory is that as the tip expands, for the tip to expand, it dissolves the tip, and then it expands into the new material. And there is a structure, sorry, I'm still learning, but that material or that structure spits out some materials, the building block materials, and then goes at the tip and it forms the new tip. But then if the tip is being continuously dissolved, how the fungi keeps that pressure alive, right?
Yeah.
Yeah, so we don't know 100% for sure. Again, the fungal kingdom is heavily understudied, but there is this new theory called as easy water theory. Do you know the fourth state of water? So easy is that if there is a hydrophilic surface, the water makes the some kind of exclusion zones because of the negative ions being attracted towards the hydrophilic zone. So it creates this negatively charged portion similar to the transistor depletion zones, and there is this positive ions that get so close and crowded together that it creates this perpetual motion of the water. And you can read about this in the book, The Fourth State of Water, Easy, something like that. So Peter McCoy argues that this might be the reason that the tip is able to dissolve, because there is an exclusion zone at the tip of the fungal tip, because it is hydrophilic. So since there is an exclusion zone, it doesn't allow the inside water to seep out. But we still don't know. That's the truth.
Well, Peter McCoy said it's probably true.
When he asked you about the mushrooms that bioremediate or eat the oil or eat the, when you showed that slide of all the oyster mushrooms that were present after eating was in that soil,
Mm-hmm.
are you saying that those oysters that just did that, you could eat those?
Yeah, why not?
Yeah, wow, okay, well, yeah.
Mushrooms grow on poop
Eating
and
shit
we
and,
eat those.
and urine and then neutralizing it and you could actually eat them. Okay, well,
There are actually tomato plants that have been grown based on top of human waste.
Yeah.
Yeah,
Mhm.
and you can eat those tomatoes.
Yeah. Mushrooms grow on cow shit all the time. Yeah, okay, so, yeah.
It has been converted into fungal sugars. That is safe to eat. Well, not all mushrooms are safe to eat. I'm not saying that. Please don't do that. Absolutely
They
not.
do fecal transfusions, so.
Whenever in doubt, don't eat. Yeah, that's the simple rule. Oh, there are multiple companies that you can buy these at-home grow kits. If you are ever into exploring mushroom, it's so beautiful. Like the North Spore fungi perfecting, I think. Yeah, you can find it in Amazon. It's a perfect gift if you want to give it to a household with
Do not
children.
buy it from Amazon, for Christ's sake.
Sorry?
Buy it from people that are
Absolutely.
mycologists or that have businesses related to.
North Spore, I bought two
Business.
from North Spore. Yeah, it's good.
There's a lot of places in Portland that you can get actually grow kits from. You know,
Oh.
from mushrooms. There's like two other.
Erie Farm, they just opened on Sandy Boulevard. They have grow kits
Oh,
over there too.
Yeah.
And
There's
they're
also.
local. Yeah.
Sorry.
Go ahead.
Oh, there's also a farm that has logs instead of like one of the food logs, like a log.
Oh. These
They're
ponds.
at the Hollywood Farmers Market.
Okay, good to know. Well, I'll be leaving Portland in
Yeah.
1 month. But it's good to know. I love this audience. It's very mycophilic. If there are no further questions, thank you again for all coming.
Thank you so much, Atul. That was phenomenal. Thank you all so much for being here with us at this Sanctum Speaker Series event. If you have any further questions about Sanctum or what we do or what we have coming up, we'll be here for a bit, so we'd love to chat with you. Thanks so much for coming. Peace.